So, in satellites, if we observe, due to the external forces, most of the times there may be change in the position of the satellite, or there may be change in the position of the antenna. Now, when there is change in the position, how it can be corrected? That's an important factor for the satellite, because if it is not in the exact radius which it has to revolve, or if the direction of the antenna is not in the exact position, we'll face lot of problems in the communication from the earth segment. So whenever there is change in the position, it has to be corrected. And for correcting the position of the satellite, or the correcting the position of the antenna, we have different methods, and among them one of the method is spin stabilization method. This method is called spin stabilization method. And if the position of the satellite has to be corrected, there are various types. That means we can say there are some passive methods or as active methods. If we use some fuel from the satellite, fuel which is stored in the thrusters, if we use, then it is called as an active method. But without using much of the fuel, if we use a technique to correct the position of the satellite, then we can call it as a passive method. So spin stabilization is considered to be a passive altitude control technique used in satellites. And why we use spin stabilization method means, because we need to maintain a stable orientation in the space. If a stable orientation is not maintained in the space, then we cannot have the proper communication with the satellite. And the spin stabilization method mainly depends upon the conservation of momentum. And how this particular method is working means, the satellite is made to rotate around its axis. And when a particular object is rotating, or spinning, it gains an energy called as a gyroscopic energy. And when it gains the gyroscopic torque, then it maintains the stable position. That means no external forces acting on that object while it is rotating can disturb the position of the satellite. That is the purpose of the spinning. And spinning an object, making it into a stable position, we call it as a gyroscopic stability. So just like how a spinning top maintains the axis stability, in the similar manner we also have the stability maintained in the satellites by spinning. And what are the key features of the spin stabilization method means, it is achieved through constant rotation about a principal axis. So we'll take an axis, and around that axis the satellite is rotated. And it requires so when we will be using this method means, when the attitude means it is the direction of the antenna. When requires a small adjustments in the antenna, then we can use spin stabilization method. And typically what type of satellites uses this method means, if the satellite is just like a cylindrical body, if it has a cylindrical body with the solar panels outside projected towards the sun, then we can use the this type of spin stabilization method. Not for all the satellites, but only for the satellites which are of cylindrical, which have the cylindrical body. And how efficient this method is means, it is because as it is a passive method, it doesn't require much of the energy. It's a low cost communication satellites and spacecraft we can use. And in this spin stabilization method, there are two types of spin. Either the entire body spins, or the most of the payload doesn't spin. In another method, we have dual spin stabilization, where one part of the satellite doesn't spin, mostly the payload part doesn't spin, and the remaining part will be spinning. And how many times it will be spinning means it spins around 3 to 16 rotations per minute. And we can see the applications of spin stabilization method in Intelsat 1 early bird satellite. So we have two types of spinning, as I do that. Either the entire body spins, including all the parts, and in another method only a particular part of the satellite will be rotated and the other part will be the in the despun mode. And what are the advantages means, because the design is simple, it is a low cost, it doesn't use any fuel, highly reliable due to fewer moving parts. And we have some limitations also: no ideal mission requiring accurate pointing, difficult mount directional antennas or sensors on spinning body. So when we space the sensors or antennas on the body, but if it spins again, there may be some problem with these parts which are connected to the satellite. That is a disadvantage which we can have. But in a cylindrical body, all these parts will be inside the cylindrical body, so it doesn't affect much. But for the other satellites, it is not possible, which are not of cylindrical bodies. So if solar panels are spinning, it may get inconsistent sunlight there. And applications in communication, maintaining orientation of earth for, because why we need to have the correct position of the antenna means, because to have a proper communication between the earth segment and the satellite. If the position of the antenna changes, then there will be problem in the communication link. So for that we need to maintain a proper communication link and a proper telemetry and tracking. For that particular purpose also we need